Yes, am I audible to all of you?
Yes, ma'am.
Now, see, in the last class, we had stopped at this question, BH is equal to root 3 BV, and we had to find out the value of theta. Shayad, you're not able to hear. Please check.
No,
Now it's okay. All right. So yes, magnetic angle, angle of dip, angle of inclination. This we had seen. I want to make you practice some more questions. Just note it down, and we complete this lesson today. See, class, this question says that a 1 meter long narrow solenoid having 1000 turns is placed in magnetic meridian. Find the current in the solenoid which neutralizes the Earth's horizontal field of 0.36 oersted at the center of the solenoid. See, magnetic field intensity at the center of solenoid. This formula, remember, Shahid, we did in the class, H is equal to Ni. When we were doing the properties, I hope you have revised this lesson, and
Yes,
Kamal
ma'am.
had asked you to revise all the properties. So H is
Yes.
equal to Ni, yes. So this is given to us as 1000 ampere per meter. All right. This is 1000 amperes per meter. See, 1 ampere, this isn't what we have discussed. 1 ampere per meter is 4 pi into 10 to the power minus 3. This conversion is very helpful for your JEE entrances. 4 pi into 10 to the power minus 3 oersted. This is something which we didn't discuss in our class, 1 amperes per meter. So since here it is also mentioned, because oersted unit is not very frequently used in your CBSE syllabus, but see in your entrances it can be asked. So do mark this as important, 1 ampere per meter. So 4 pi into 10 to the power minus 3 oersted. All right, so if 1000 is there, right? This is 1000 I. 1 ampere is 4 pi into 10 to the power minus 3. So for 1000 will be divided. So this and 1000 will be cancelled. See, for 1000 current ampere per meter, it would be 4 pi into 10 to the power minus 3 multiplied to 1000, that is 10 to the power 3, it will be cancelled. So this becomes 4 pi I amperes per meter. First step. This much is oyster. Oh, sorry, not in amperes per meter. This is in oyster. Oyster. All right. Now see how much is it given? How much this is equal to? This is the magnetic field. How much this is equal to? This is neutralizing what? This is neutralizing. This is neutralizing here means balancing. It means here it is balancing. It means the magnetic field is 0.36, right? Question is very easy. It's not difficult. It's just that this part was confusing. Now see, magnetic field is given 0.36 oyster, right? This is already given to you. So it means you can equate both of these. So 4 pi I is equal to 0.36. Current is 0.36 divided by 4 into 3.14. All right. Solve and let me know what's the answer. I think the answer is something in 28 something. Just note it down. Check it. Let me know. I'll also let you know the answer. I don't remember the exact value right now. Note it down. Now, see, there are different types of galvanometers. So in your CBSE syllabus, we didn't have the types of galvanometers, right? But in your JEE exam, you have to focus on different types of galvanometers, especially those have certain laws. Like one or two I will discuss with you, which are important. One is known as tangent galvanometer, because based upon this, you will have numericals. So that's why you have to know the basics of this. Tangent galvanometer. See there, it's also it's just a similar galvanometer. The way definition of galvanometer you have studied that galvanometers do what? They detect current in your circuit. They just detect current. Shahid must have idea. Fadil, you must not have this idea that you have in your circuit voltmeter is there, ammeter is there, galvanometer is there. So the amount of voltage, the magnitude of voltage is measured by the voltmeter. How much current is flowing in your circuit is measured by ammeter. But whether in your circuit, if the current is present or not, just a yes or no, that is given by the galvanometer. If there is a deflection in the galvanometer, it means there is a current in your circuit. Now, how much is the current, whether it's 1 amperes, 2 amperes, that is given by the ammeter. All right. So here also tangent galvanometer also just detects the current. It won't give you the exact magnitude. It's just that if the deflection is more, the magnitude of current must be more in your circuit. If deflection is less, it means a very slight current is flowing. That's why we have a concept known as sensitivity of galvanometer. When we say na galvanometer is sensitive, it means for a very small amount of current, the galvanometer is showing a huge deflection. So it means that device is sensitive. So sensitivity also has to be kept in mind. Now, tangent galvanometer, there is one principle on which it is based. Let us discuss that principle, which is important to you. This is known as tangent law. This is known as tangent law. See, tangent law basically says that if the current is passed through the vertical coil of the galvanometer, if current is passed through the vertical coil of galvanometer, then magnetic field produced is perpendicular to the magnetic meridian. All right, it means the horizontal component of magnetic field is perpendicular to the magnetic field that is produced in the center. This is just the law which you have to remember, and that is helpful for you. Now, let me draw the needle first, because this is actually present inside the galvanometer, so we don't pay attention to it. We actually just see the scale which is drawn outside, and scale moves, which gives us the direction. Just pay attention to this, that is enough. You don't need to go into the details of the tangent law. See, if there's a coil present, this is it. This is suppose the magnetic meridian. Suppose this is the magnetic meridian. Now, there is a magnetic field at the center of the coil. This is the magnetic field at the center of coil. There is a magnetic field which is perpendicular, right? So one angle we'll take theta, other angle we'll take 90 minus theta. Just have a rough overview of this. You just need to solve the numericals part from this. Now see, when I say BO, that is torque on the needle at the center. See, two magnetic fields are there, right? Magnetic field which is present at the center, and the horizontal component of magnetic field BH and B naught. When I calculate torque on needle due to needle due to B naught, that is magnetic field which is produced at the center. So I told you 90 minus theta will be existing. So the formula will become torque is equal to MB. Magnetic field will be B naught. MB naught sine 90 minus theta. And similarly, when I have to find BH, that is magnetic field due to the horizontal component, it would just be simply here magnetic field will be H and sine theta. That's it. Now see, both torques that are produced are actually equal. These torques they are equal in magnitude, because This is the condition I am talking when equilibrium has been achieved. It means the deflection has stopped now. See, initially when there has been a detection of current in the circuit, the deflection of the needle begins, right? Now, at a certain point when the deflection is completed, the needle stops and then comes back to zero when you switch off the circuit. So that moment when the needle is temporarily stopped, that is known as equilibrium condition. So in that case, both the torques are equal. Both the torques, anti-clockwise and clockwise, are balancing each other. That's why no, the needle is not moving further. We are getting equilibrium condition. So that's why you can equate them. So MV naught sine 90 minus theta becomes equal to MVH sine theta. From here, again, you have V naught. The M will be cancelled. Sine 90 minus theta is cos theta. So this is V naught cos theta is equal to VH sine theta. B naught is equal to BH sine theta by cos theta. All right. So, which you can further even write it as BH tan theta. So, it's very similar to BV and BH, what we had obtained initially. And also one thing, class. Here, no, in a tangent galvanometer, you have a circular galvanometer and a solenoid is present. And this solenoid is present. So, we write this magnetic field at the center, which is produced usually as mu naught Ni by 2R. Fadil, you must not be remembering this. This is magnetic field at the center of a circle. This is the formula, magnetic field at the center.
Yes,
We will derive it in our class. Okay. Shahid, I hope you remember magnetic field at the center of a circle, mu naught Ni by 2R.
yes, ma'am.
So you can use B naught as mu naught Ni by 2R also in your calculations. Fine. So then again, sensitivity part comes. Just remember, I'll not tell you the derivation. Just remember that galvanometer, tangent galvanometer is sensitive when the deflection is 45 degrees. There is a whole derivation for this. You do not need to go into the details of it. Even the questions in JEE entrances are also very less from tangent galvanometer. But still some questions have come in the past year. So that's why we are discussing it. Note down this part. Then we'll see if important questions are there from this. See, two tangent galvanometers A and B have the number of turns in the ratio 1:3 and diameters in the ratio 1:2. Now, which has a greater reduction factor? You have to tell which of them has a greater reduction factor. See, what is reduction factor? It is actually a constant. Now, a reduction factor of a tangent galvanometer is basically equal to the degrees it is holding, number of degrees, or current actually. To be precise, no current it is holding. Let me tell you, I theta is actually equal to I. The actual formula no of this is reduction factor. Reduction factor occurs when theta is 45 degrees. That is when the galvanometer is sensitive. So current becomes equal to K tan theta. This is the formula. So current becomes equal to A K tan 45 degrees. So current becomes equal to the reduction factor. All right. Now see. Now what you have to do? Current is equal to the reduction factor. So number of turns you will focus. You will focus on the number of turns. What is given to you? Number of turns in A by number of turns in B is given as 1/3, right? This is given to you. And the diameter ratio, or you can say radius ratio, because ratio of the ratio radius will also be the same. So 1:2, this is given. Fine. Now when you will compare, you will just compare it with the radius. That is enough. You will compare it with the radius. K, or take the ratio Ka by Kb. That is current you have to find out. Current is directly proportional to K, that you can see. When we're talking about the reduction factor is actually equal to the current. All right. And even the SI unit, when we talk about reduction factor, the SI unit is also amperes. This is so much similar to ampere. Now, class, when we come back to this question, we know what is reduction factor. Reduction factor here will also be Ka by Kb. Ka by Kb. So it is basically the ratio of this and this here. B is equal to mu naught I by 2R if you use this formula. So from here you can see this is directly, current is directly proportional to R by N. So you can take the ratio R divided by N. So Ka by Kb is 3/2. So clearly you can see Ka is greater than Kb. Again, I am mentioning this is not part of your CBSE syllabus. Please don't revise it for your tests and all. Now, second part is which galvanometer has shown a greater deflection when they are connected to in series to a DC source. Okay, see. Which quantity remains same in series connection? Yes, Fadil, this so you also now must be knowing this. We have discussed this. Which quantity will remain same? Yes, Shahid, right. Current. See, Fadil, I told you, no, charge in capacitor and current in resistors. This remains same in series connection. So since it is
Yes, ma'am.
the series connection, this means current is remaining the same. All right. And I is equal to K tan theta. This also I've told you. So if Ka is greater than Kb, then what about tan theta? Tan theta A will be less than tan theta B. So theta B will be greater than theta. This is the ratio that you have to consider. Now in your exam, this will be, so deflection is this, deflection is theta. So this is how you will get theta. So in your exam, you will have 4 options like this: theta B greater than theta A greater than theta B, theta and theta B equal, or 2 times greater, like this you will have the option. Note it down. All right, Shahid and Fadil, this completes this lesson. This is just the galvanometer which I wanted to discuss with you, tangent galvanometer. Just revise it. This is important. Rest of it in this lesson is that theory part, paramagnetic, diamagnetic, ferromagnetic substances. So I have shared it on the group already with Shahid. Fadil, this will be done in the lesson in your class, because see, this is there isn't any difference when it comes to those portions. What was different we have discussed. Now we'll straight away start